Welcome to Physics Clinic at the Red Rose Academy. Today's topic is, we'll see. One second. Welcome back to Physics Clinic at the Red Rose Academy. In continuation with the last topic, we'll see today the collision theory. Okay, so it's very important and crucial for your board exam. You have to learn collision theory along with me right now. Okay, students, I'm again and again repeating, you can learn along with me. So it is easy for you and save your time also. So always keep book with you while watching the video. Okay. So this video lesson is not like the others, I mean, I can say the other videos are, I mean, highly, it is not exactly the text from the book and all. So I'm teaching from your book only. So you can take your book, notebook along with you so that you can able to learn with me in this video lesson. Okay. So right now we'll see collision theory. Collision theory, it provides a theoretical explanation of the rate of a chemical reaction. You know, if the particle started moving, definitely the collision takes place, right? So, and how it is depending on the temperature and concentration. Everything we saw from the beginning, but this theory, it was developed independently by what is the scientist's name? Trotz, Max Trotz and William Lewis. Okay, in 1916 to 1918, like that. Okay. So it is based on the kinetic theory of gases only, kinetic theory of gases. This theory assumes that because if the molecule started moving, definitely by the virtue of its motion, we can say kinetic energy is there. Okay. So here what is happening? So it is basically due to the kinetic theory of gases. Okay. We'll see now. The reactant molecules are hard spheres. And like that, this theory assumes. How about the reactant molecules? It is a hard spheres. And that a chemical reaction occurs only when these molecules collide with one another. This is what it says. Okay. It is given in your book. Then, what is this? Okay. Collision frequency. What is the collision frequency? The collision frequency is categorized by a letter Z, the number of collisions per second per unit volume. Okay, number of collisions per second per unit volume of the reaction mixture is known as the collision frequency. Okay, it is for a bimolecular reaction involving reactants A and B now, the collision frequency is denoted by the letter ZAB. Like this. Okay, rate is equal to ZAB e power minus EA by RT. Okay. Then, what is given in your book? Okay. Equation 4.23 predicts the value of rate constants fairly accurately for the reactions that involve atomic species or simple molecules. But for complex molecules, significant deviations are observed. So we'll see, first of all, what is the effective collisions? See, you had to say what is the activation energy and energy barrier we saw. Activation energy. And this is called the energy barrier. In catalyst, you can see. Okay. So what is the potential energy barrier? I have told you, no. So the activation energy we saw with respect to the potential energy, the number of molecules attaining the energy we saw for different temperatures, for different reactions, right? So the activation energy, you can able to see in this graph, right? This is the activation energy. Okay, and it slows down when the product is received. When the product is formed, it slows down. That means the potential energies act like a barrier. So even then it is the molecules, some of the few molecules are moving through the barrier. That and all we saw already. You can pass the video and look into the previous video so that you can able to understand very easily. So the reason could be that all collisions do not lead to the formation of products. That's what I'm trying to say. Not every collision results in the formation of products. Okay. If every collision were successful, all reactions would finish in fractions of second. Is it so or not? So what is the effective collision? For a collision to be effective, that is, it results in a chemical reaction. The colliding molecules possess a certain minimum amount of kinetic energy. Okay, that is effective collisions. So what is an effective collisions? Let me repeat again. What is that? Okay, and also the collisions in which molecules collide with sufficient kinetic energy. Okay, we saw that, right? That is the threshold energy. So, for a collision to be effective, the colliding molecules must possess a certain minimum amount of kinetic energy. That is the threshold energy. You saw in photoelectric emission, right? Last year in chemistry, structure of atoms, you have studied about the, uh, I mean, what is that? Photoelectric emission. In that, you have seen threshold frequency, right? So, if a light is an incident on the metal target, the metal target won't emit electrons immediately. Okay, after achieving some photons. So that means the frequency should reach its level. That is the critical level. That is the threshold level. After that only it started emitting the electron. The same like each and every molecule should possess a certain minimum amount of kinetic energy. That is the threshold frequency. So sorry, threshold energy, threshold kinetic energy or threshold energy. Okay, and to facilitate the breaking of bonds between reacting species and formation of new bonds to form products are called as effective collisions. Okay, then what is an activation energy? We already saw this is the minimum extra amount of energy absorbed by the reactant molecules to form the activated complex. We saw that, right? So that's what in between it forms the activated complex. Here, activated complex in this, right? So but this graph, it shows a catalyst, okay? So it is the reaction path without catalyst. It is the path with catalyst. We saw, right, it will alternate the path. So that's what given here. But you know, at the activation energy, the minimum amount of energy which is absorbed by the reactant molecules, there only the activated complex, intermediate complex is formed, right? And then you know the mathematical expression, right now you have learned about all these things, A plus B, it gives products, right? Example, it is given methyl bromide plus OH minus. It is an example given. It gives CH3OH. So methyl alcohol plus bromine. See, you know, the bonding between these two will be, it is delta plus carbocation and delta minus carbanion. So it is not carbanion, it is carbocation and it is the more electronegative. So you know this bond may breaks and this OH minus hits, right? Like this. See, the orientation also change. That is what it is very important. By means of this minimum amount of kinetic energy, that is the threshold energy, the orientation also be proper. Okay. See, right now the orientation changes like this. Okay. BR is here initially, improper orientation. Proper orientation is BR and here only OH joins. Got it? Okay. So this is, intermediate. So you have learnt about the SN1, SN2 mechanism, right? In SN2, SN1, you saw both, right? At the same time, SN2, right? In SN2, the attacking group and the leaving group are, simultaneously it is in the molecule, it is in the compound, so that it is very heavy, right? So the same like the intermediate has both the attacking group and the leaving group. So this OH is the attacking group, bromine is the leaving group. Now it left. Okay, so after that, you'll be getting the alcohol and bromine. Is it clear for you, this one? So this is easy only, you know all these things. Okay, so what is the orientation factor? The proper orientation we saw, right? Actually, experimental rates. Suppose if you are, while the equation above works well for reactions, for example, it involves simple atoms or simple atomic molecules. It fails to protect accurate rates for complex molecules. Now, what we can able to say, the orientation of the molecule only we have to take care of. Suppose, if you see what is the problem may occur. Experimental rates for complex molecules are often much lower than calculated rates. Always it will be like that for complex molecule. Experimental rates are much lower than the calculated rates. This implies that even if molecules collide with sufficient energy, they might not react. Can you able to get the point? So that is the problem. So what is the solution in this? If the problem is there, what is the solution here? You saw the formation of methanol from bromoethane, right? Formation of methanol from bromoethane. So what is happening here? Okay. So proper orientation of the reactant molecules lead to bond formation, whereas improper orientation makes them simply bounce back and no products are formed. See, this is the problem. Okay. So even if the molecules collide with sufficient energy, they might not form any product. So the solution is the colliding molecules must also have the proper spatial orientation. So proper spatial orientation, this is very important. The collision, it is very necessary. Okay. At the moment of collision. So that is what you have to understand. So at the moment of collision, to facilitate the breaking of old bonds, the formation of new bonds, that is in the reactants breaking of old bonds, to form the product, the formation of new bonds are necessary. So collision is needed there. At the moment of collision only, the molecule becomes the intermediate gets the proper spatial orientation. Okay, then one more thing. So the probability. So how much effective the collisions will be. To account for effective collisions, another factor P called the probability or steric factor is introduced. What is the steric factor? To account for effective collisions, that is the probability or steric factor. So this is the probability or steric factor. That is the proper orientation. It talks about the proper orientation only. Okay. Formation of methanol to, so bromomethane only here, right? Bromomethane. Okay. So we saw that, right? Rate is equal to P into ZAB. A and B will be E power minus EA by KT. So the P is nothing but it is the steric factor. Okay. So what you have understood, thus in collision theory, activation energy and proper orientation of the molecules together determine the criteria of an effective collision. Okay. Then, okay. So collision theory has also has certain drawbacks. Okay. So what is the drawback? We'll see now. Before that, you must understand improper orientation doesn't produce any product, and proper orientation only produces the product. Okay, so what are the criteria we saw? Energy criterion. First, for a chemical reaction to occur, according to collision theory, two conditions must be met simultaneously during a molecular collision. One is energy criterion. I already told you that is the threshold energy. That is activation energy. The colliding molecules must possess sufficient kinetic energy. That is the energy criterion. And the other criterion is orientation criterion. Orientation is the molecules must be properly oriented in space at the exact moment of collision. Okay? Otherwise, no product will be formed. Then, what is the drawback of the collision theory? Okay. Drawback will be, I can say, the primary flaw of this theory is that it consider atoms and molecules as hard. That is its primary assumption. Okay? Hard and featureless spheres, and completely ignores their complex structural geometries. That is what the problem is. That is their drawback. Okay? So, okay. So, as you said, as it is given in your book, it is given in the higher classes. Okay. So this lesson is over. Then I'll give you some questions based on this. Okay. Can you take down the questions as an assignment? Hmm? And for before I give you the problem, you must understand what for numericals you have to go through the formula. Okay. And for graphical analysis, you have to see a lot of graphs in this, right? It is very crucial for MCQs. You know, right? Natural ln we saw ln is equal to ln A minus EA by RT, everything you saw. This is the natural ln. Okay, you need to understand the graphic analysis between this, and you are converting this to the log to the base 10. So what it will be log to the base 10k. I've already taught you all these things. It is equal to minus EA by uh, minus EA by 2.303 into RT. We saw this, right? So the plot, if you graph log to the base 10 on the y-axis against 1 by t, you get a straight line. Okay. What is the slope? Minus EA by 2.303 R. Okay. So y-intercept is log to the base 10 A. Okay. This is the y-intercept. So you have to understand what are all given in this. This minus of minus will be plus A. Plus it will be. So increasing slope. So you must take a note of all these graph analysis. Graph analysis is very important. Don't simply put like if it is given you natural ln under log to the base 10, it won't be same. Okay, so make a note of this. And one more thing I want to give you an idea for numericals, two temperature formula. We saw that, right? What is the two temperature formula we saw? Log to the base 10, K2 by K1. I remember that, right? When EA by 2.303, 2.303 R into here T will be difference in temperature. So that is T2 minus T1 by T1, T2. That is 1 by T1 minus 1 by T2. It will be like that. Okay. So these are all the tips for problem solving. Definitely you must take care of the units also. Okay. So units also very, very important. I'll give you some questions to solve. Okay. So these are all the questions. Take down these questions and take down the problem number 1. Okay. So, right now integrated law, rate law and differential rate law. So it is very important for board exam as well as the NEET, JEE and everything. Okay. I'll give you this first question. Take down. A first order reaction is 20% complete in 10 minutes. Calculate the time taken for the reaction to be 75% complete. Okay, so first order reaction only. What you have to do? So what is given here? First, let initial concentration. We can take, it is 20%, 70%, so you can take 100% like. Okay, then for 20% completion, what it will be? T1 is equal to 10 minutes, right? And what is R of T1, we can say? R1 or R of T1, we can say. So 100 minus 20, it will be 80 there. So what is the rate constant? 2.303 by T into log of R not by R, right? R of R1. So 2.303, time is 10 minutes, and the log of 100 by 80, right? Okay, so what is the answer coming? You have to find out. Okay, so I have converted this into log only, so we can find out easily. Log 100 by log 10. Okay, so you need to find out log value. So I will teach you now how to find out the log value. Okay, so 2.303. Then right now we will find out log value. What is 10 by 8? 10 by 8 is 5 by 4. Okay, so what is 5 by 4? 5 by 4 is 1 point, and then it is 10, right? 2, after that 5, 1.25. So now we are going to find out log 1.25. I'll show you the log table. Log of 1.25. Okay. This one, log of 1.25, right? So for this, how you can take? See, for example, $12, right? Can you able to see this? 1 second. So I hope it is very clear for you, the values and all. Okay. So right now I will teach you. So we are going to see log of what? 1 second. We are going to see log of 1.25. Okay. So first of all, you should understand how we can able to see log. Okay. So in log, you have to characterize you should split. Okay, the log has two parts, before decimal and after decimal. Before decimal, it is characteristic. Okay, in log, you should do that. Okay, so what is the before decimal? It is characteristic. So after decimal is mantissa. So these two parts you must understand. So before decimal characteristics are exponents of 10. Okay, exponents of 10. And after decimal characteristics, mantissa you are taking, right? So this is the main, after decimal, how we can able to see everything I will teach you. If it is 1.25, 1 is the characteristic and 0.25 is the mantissa part. Okay, so first of all, you must understand what is characteristic part, what is the mantissa part. Okay, so to take up the logarithm, suppose if the characteristic can be positive or negative also. Okay, wow. For example, I can say the negative characteristic is written as a bar also. Like this also you'll be given. Negative characteristic. Okay, but the mantissa is always a positive decimal less than 1. Since it is point, right? So definitely it will be less than 1. Okay, so mantissa part is always positive and less than 1. Okay, so this you have to keep in your mind. Suppose if you are given the characteristics as 1 point, so you have to take the reading as 0 point. If the characteristics begins like 15.27, then you have to see the digits, 2 digits, right? Here it is 1 digit only. So 2 digits, so it will be 1 point. Is it clear for you? Hmm? If the characteristics is 2 digit, it is 1 point you have to put. If the characteristics are 3 digit, then 2 point you have to put. Okay, after that only you have to look into the table. Suppose if it is a log 1, it will be 0, 0, 0.00 like that. You should reduce 1 further. So if it is 1 digit here, you have to reduce 1 digit and 0 point. If it is minus 1, you have to reduce again 1. So it will be 0.00. After that only the number comes. Okay, is it clear for you? This is for log. Okay, log value. And I will teach you about antilog also. Suppose antilog, it is the exponents of 10 means that is the multiple of 10. See, antilog of some x number is multiple of x, like this. Okay, suppose if you want to find the antilog of this number, 2 point like this, then after finding the antilog of the number, you have to put the decimal for 3 digits. See, the antilog of this is 5002. You have to see antilog for only these two. Okay, I'll teach you all these things. Okay, 69 in the left column, here in the left column, and 9 in the top, and 2 in the mean difference. I'll show you all these things. Then if it is 2, you need to add 1 and put the decimal after 3 digits. Okay, antilog will be, you have to take care of this number and do remind for the answer you have to add 1 plus and it will be 3. So after 3 digits only you have to put the decimal. Okay, but you need to see the antilog table only for these 4 numbers. Okay, this is what we are going to see. So I'll teach you all these things right now. For 1.25 we'll see. Okay, what is for 1.25? I told you for log 1.25. Okay, 1, right? So 0 point. Keep this in your mind. But for log, you have to take all the values. Okay, for only anti-log, you have to consider after the decimal point. Okay, so 12. So 12, here it is 12. First two digits, first two significant figures in the left column, and the third digit in the top. So 1, 2 means it is here. Okay, sorry, 5, right? 5. So 0.06969, 0.0969. Okay, and there is no mean difference here. That means if there is another digit like 1 here, then you have to take 1, and in this particular row itself, you have to add the mean difference plus 3 here. So it will be 0.0972. Like that it will be. Clearer? If there is any mean difference, the mean difference comes in fourth digit, okay, fourth significant figure. Then you need to see the mean difference and add the mean difference with the number. Now there is no mean difference. So what is log value? Right now I will see. I will show you. This is the log value. What we saw? 0.0969. Okay, so this is the log value. And 2.303 by 10, you can take 0.2, like, okay, 0.2303 into 0.0969. So what is the answer? I'll use the calculator. Okay. Okay. 0.2303 into 0.0969. So what is the answer coming? 0.0223. You need not use the calculator. You have to do multiplication like this. Remove all the decimal points and do the multiplication like this. After getting the answer, you can count the digits. Here also 4, 4. So 8 digits. Before 8 digits, you have to put. So it is minute inverse because it is in minute. Okay. Like that for 75 completion, you have to find out. Okay. And then find the log value. Everything is easy only. Okay. So for 75% completion, I'll teach you some tips like 75% completion. What is the R value? R final. Huh? It is 100 minus 75. It is equal to 25. So in the place of 2.303 by K into log of 100 by 25. Right? So here also the same